Hi, welcome back to the breadboard. Today we have a review video. I was sent a package from a company website called HSU Store, which is on Amazon. They also have their own direct website. And what this is a complete Arduino and Raspberry Pi starter kit. It is an advanced model and they sent it to me to review. So let's get to the bench and have a look. So here it is. I've taken out the shipping packaging, but this is how it arrived to me. HSU, as you can see here, stands for Happy Share Up. So the HSU shop sells quite a range of different products, mostly GoPro and camera accessories, but they do have a selection of development kits for the Raspberry Pi 3 and the Arduino. And the one we have here is the advanced kit. And according to the website, it has 16 different sensor modules. So without further ado, let's get this cardboard box open and see what's inside. First thing we notice right off the bat, the whole kit is contained in a what looks like very nice ballistic style fabric case. It's quite stiff. It's not solid, but it's quite firm case. Got a carabiner, carry handle. Everything is contained within here. It looks like it's all zipped up. Very nice. So let's get this open and have a closer look. Okay, so here we are opened up. Looks like we've got quite a range of different things all packaged in the box here. Got a sheet of paper that seems to list the sensor module. So according to this, we have a DHT11 temperature humidity sensor and SR501 human detection sensor module. That's just basically a PIR. Trickle charging timekeeping chip, raindrop sensor module, sound sensor module, ultrasonic distance module, flame detection sensor. I think that might be just an IR sensor. Laser transmitter module, photodiode light sensor, soil moisture sensor, obstacle avoidance sensor, so that's going to be a LED transmitter and receiver, vibration sensor module, smoke detector, wireless transceiver modules, probably in the 315 megahertz, tilt sensor, and a what is described as a channel infrared tracing tracking sensor module. So that's the 16 different sensors, but of course there's a lot more than that in this package. So I'm just going to take everything out and lay it out on the bench, and we'll go through them. Okay, so just starting from the outside, this is the case that everything came in. And as you can see, we've got a zip-up pocket at the top where you can stuff your cables and things like that, and you've got a big basically a tray where you can put everything else. It was all stacked inside here, so you know it's going to fit. Now this kit does not include an Arduino or a Raspberry Pi, and according to the outside of the cardboard box, this is a Raspberry Pi specific version. Don't know whether there'll be anything specifically except for maybe a header board to the Raspberry Pi on here or not, but let's find out. Anyway, I've got everything pulled out here. Let's just pull things, arrange them a little bit better, clear a bit more space on my, got some bags of bits. Let's get through, I think, some of the bigger items that are Raspberry Pi specific first. So we have a HDMI to VGA adapter for the Raspberry Pi. Now these would typically be powered to do their job properly. So let's just open this up and have a look. Okay, so yep, this is a it's got screw connection so that you can positively lock your VGA cable to it, which is nice. HDMI connector on the other end. Not sure if I have a VGA monitor anymore, but I'll see what I can do. And it looks like we have a power or audio out, maybe. I'll have to check that. It plugs in the side here, but it doesn't have any markings to say what that is. Now I do know that the Raspberry Pi, of course, outputs audio. So it is possible that it is outputting audio. We have a Ethernet cable, standard, probably a Cat 5 or something like that, I would imagine. Let's have a look. Does it tell me? Yep, Cat 5 UTP 26 gauge 4 pair. We have HDMI cable, so we're going to plug directly in with HDMI. So that's that. Let's just move this aside a second. These are all more Raspberry Pi specific. We have a power supply, USB power supply. This one is, let's have a look at what the rating is. 5 volts at 2.5 amps, so more than capable of supplying a Raspberry Pi and a bunch of accessories like an LCD display and things like that. Looks like we've actually got a positive power switch even in line with the cable that they provide. It feels like it's a fairly substantial cable. We'll find out when we power it up, of course, if we get the little rainbow indicator for low volts or anything like that. So there you go. That would also, by the way, power an Arduino, or some of them. It does have the micro USB connector, so that will go directly in a Raspberry Pi. But a lot of the Arduinos, of course, have bigger adapters, so it wouldn't work for those. But then you could always just plug a different USB lead in here. And I think the other part that's in here that is specifically Raspberry Pi is what looks like a header breakout board in this anti-static bag. So I can get into this 1 second. So I can just zap the packet open. Tell you what, for the rest of these, let's bring the camera in closer to the table. That will be easier, I think. Okay, so here we are. This is the board that I just pulled out of the bag. It looks like a fully pulled out expansion board. On the back, it's got a little bit of writing here. It says Raspberry Pi 2/B+ GPIO expansion board E, presumably E for revision E or expansion E, I'm not sure, but anyway, we've got a plug to go into the Raspberry Pi. It's a full 40 pin, and we have the, I guess you'd call that a socket, not a plug, and we have the pins on the top so that you can expand out to something else if you want to. And then we have a set of what looks like jumpers. There's a little bag that comes with it full of jumpers and screw headers and things like that, that looks like it will allow you to jump it here and take these connections to these quick push connectors, and where you can run some jumper wires out from them. Anyway, it is definitely for the Raspberry Pi, not the Arduino. That won't plug into an Arduino, of course. And I think that's everything that is specifically for a Raspberry Pi. So let me just pull out the other items, and I'll lay them out and we can have a look at those. So the first thing we have here, just starting with some of the bigger items, I guess this also Raspberry Pi specific, are a couple of Raspberry Pi prototype plates. Looks like you can screw mount your Raspberry Pi up top here, and a solderless breadboard on the bottom, probably double-sided tape it or something like that, and it will allow you to just have a nice little prototyping arena for working on your projects. And there's actually 2 of these in this kit, so enough for 2 Raspberry Pis, I guess. I don't know whether it's meant to have 2, but that's what mine comes with. The next thing that is fairly generic but is essential for prototyping and playing around with electronics, a pair of solderless breadboards, 1 complete row, 5 pins on each side, power rails on both sides for both positive and negative, and it looks like we have 65 rows of pins, so you can get quite a bit of project work done on one of those. That would probably, yeah, it's got double-sided tape on the back, so that would allow you to basically stick it onto this Raspberry Pi prototype plate. Kind of cool. And we've got a pair of those So here's the second one. It's exactly the same as the first one. It interconnect any components with 20 to 29 gauge 0.3 to 0.8 millimeter wire. We have a bag full of bits and pieces here, so let's just tip that out and have a look. They're all individually wrapped inside. These are probably all of the sensors. So let's just start working through these. They're all sealed. So here we have what I think they call the raindrop sensor. Let's just start pulling these out of the bag as we go. So basically, most raindrop type sensors, what they are is an array of copper tracks, PCB tracks on a board, and when the rain or moisture hits it, it creates a bit of conductivity through here. And what you probably have on here is a little op amp with a threshold level, and you have this feeding out to an analog to digital converter probably. There's an AO, a DO, a ground, and a VCC. So this is probably, as I said, a comparator. Let me just see if I can get a magnifier and tell you exactly what that chip is. Yeah, so the chip on here is an LM393. It is a low power comparator. For a Raspberry Pi, you probably just use the digital output. So that's a raindrop sensor. Next one up, I'm just grabbing these as we go, no particular order. This one looks like the infrared transmitter receiver, so obstacle avoidance sensor, I think they called it. So what we'll have here is we'll have a infrared transmitter and a detector, so it will see any reflections. Okay, so that's what we got for that one. This is, in case you're wondering, this is an anti-static bench, so no worries about damaging anything. Next up, we have what looks like a laser module. Looks like this is a laser diode in here. It's the kind you would find in one of those little pen type lasers from the dollar store or the pound shop, depending on where you live. So that's your laser transmitter. These are all designed, they do have little screw holes in a lot of these, so that you could mount them on something if you wanted to. But mostly they've got the pins on them so that you just plug them into the flying cables. So next up, we have a real-time clock module. So room for a CR2032 battery, and what we have in here is a DS1302. I think that's a Dallas, an oldie but goodie Dallas Semiconductors real-time clock chip. It is, you've got clock, data, reset, ground, and VCC. Nothing on the back. So that, let me just quickly check that, what that is. So it's from Maxim. It used to be Dallas that were famous for the timekeeping chips, but now I think they got bought by Dallas quite a while back. Trickle charge timekeeping chip is the description. Completely manages all timekeeping functions down to seconds, minutes, hours, day of the month, day, week, year, etc., etc. Battery backup capability, 3-wire interface. Okay, next thing up, we have the smoke detector. This is a fairly standard smoke detector module. I don't think, oh, it's got an MQ-2 written on it. So again, you'll have probably an op amp of some kind. Nope, another comparator and setting. So it's going to give you an analog output from the smoke detector probably. You set threshold and it'll give you a digital output if it goes above that threshold. Suitable for H2, LPG, CH4, CO, alcohol, smoke, and propane. That would require something a lot more expensive and calibrated probably. Detection of certain components in the air usually requires a more precise and costly instrument, and cannot be done with a single gas sensor. If a project is aimed at obtaining the gas concentration at a very precise level, then do not use this sensor. All right, next up, we'll grab this. Oh, that's the PIR sensor. So what we have here, inside here, will be a light. It's more than a light, it's infrared, but it's sensor underneath here. I don't know if I can just pull this off. Yep. So we have a little sensor module here for passive infrared. Usually it's two sensors, and it does like a differential measurement, and using the chip and things, it will figure out whether there is something moving in front of it. The adjustments are usually time and sensitivity, so how long it would be tripped for if it does get tripped, and then how sensitive a change to the movement that it would be. So you could adjust it to ignore cats, for instance. They typically just have a power and a output, which indicates whether it's triggered or not triggered. So that's hence just the 3 pins. So there we've got the movement detector. They called it human, but it doesn't have to be human. It will be anything that is moving. Next we have, this is the vibration sensor. It's probably got a little ball bearing or something like that inside here. And what happens is any vibration, and it will be breaking the contacts across here, or making them. And that will then trigger out to the Raspberry Pi, or whatever you hook it up to. A couple of capacitors and things, but other passives on here as well, probably for debouncing it a little bit so it doesn't prematurely trigger. Anyway, vibration sensor. This one will be the temperature and humidity sensor, DHT11. Done lots of videos using these before. They're very useful. The DHT11 versus the DHT22 is just a matter of range. If you want to go to sub-zero and things like that, then you need the DHT22. Now these humidity sensors, and pressure sensors as well, as it happens, always have a temperature sensor built into them as well, because the humidity and or pressure is actually dependent, or changes depending on the temperature. So that's why they always provide a temperature measurement too. Okay, next up, soil moisture indicator. Basically, this is good for gardening type of projects and things. What you have is basically a stake. It's pretty much just PCB. They've plated the contacts. You stick it in the soil, and it measures the conductivity. So very, very similar to the rain sensor, only this one would be in the soil for a while. Now, depending on what they've coated this with, one of the downsides of a lot of these is that they will corrode because of being in the soil over time. So you just have to be aware of that. After a year or so, you may have to replace the probe here. But these should be pretty darn cheap to get replacement probes. On the other side, it's probably going to be the same LM393 as a comparator, because it's pretty much the same circuit. Yep, same detection. So that's probably a fairly common board across a lot of these things. Okay, let's just clear a bit of mess. See if we can speed up a little bit. I might have got, where is it? This one wrong. One of these is a tilt switch. It might actually be this one. Yeah, I think this one's the tilt switch. And this one I think might be the vibration switch. They both work fairly similar ways. They've got a loose item inside this little tube, and one of them will be very sensitive to just general vibration, whereas one of them should be less sensitive to vibration, but more if it tips. Great for doing booby trap things, like making games where you have to try and carry something across the room and not tilt it and stuff like that. So worthwhile having a little play with those. It will be fairly straightforward software to get them working. So actually a lot of these, because they're all using an LM393, should be fairly easy to use. Okay, this one is the sensor that would be used for line following and things. So what you have is you've got a transmitter and a receiver, very, very similar to this one. This one they're calling a obstacle avoidance, where it will be getting a reflection if anything gets too close to it. In this case, what they're doing is they're actually beaming down, and they're trying to, and you're looking for a reflection over time, as opposed to the other one where it's pointing out front. They're going to work on a very, very similar principle though. So probably again another LM393. Let's just check that. Yep, another LM393. So there is that one. Okay, next up, infrared receiver or light sensor. Again, the LM393, adjustable pot. Same basic kind of idea. This will probably pair nicely with the laser transmitter. Sorry, that's not the laser transmitter. This one is. Here we have a standard light sensor. Again, what we've got is the photoresistive sensor on the end here. I've done a few projects in the past using similar kind of sensors. We've got the LM393 op amp and an adjustment, and what you can do is you can adjust this so that as you get darker or lighter, the state of the output of the comparator will flip and tell your remote end that it's light or dark, for instance. So if it gets dark, you can indicate to the Arduino or the Raspberry Pi that it's dark and turn a light on, or do something else. This one also has the 4 pins, not the 3, so it's supporting both the analog value of the sensor as well as the comparator output, which will be a digital output. There's a light sensor. We're nearly done here, I think. At least as far as the sensors are concerned. This one looks like a sound sensor. So you have a little microphone here. LM393. There's a transistor and a bit more passives on this one. This one, what it'll do is it'll be detecting any noise on here. You've only got the 3 outputs, so it's not going to be an analog output. So this one would be for sound. Maybe make a clap light switch or something like that. There's a bit of fun. This one is 2 modules in here. This is the radio module. This one you might need to use 2 microcontrollers. I mean, it's not essential. You could just transmit and receive by the same one, but then why would you? So what we have here is typically this would be the, see if I can figure this out without, got the antenna, does it say? Not sure what that chip is. Let's get the magnifier on and have a look. LM358. So that's an LM358 on there. So this is going to be the 355 megahertz transmitter receiver, but we'll see what the LM358 is. So it's actually simply a dual op amp. So this must be just a very, very simple tuned oscillator. We can power that up and check it later because I have a scope that will let me look at the output up to 500 megahertz. And I've also got a spectrum analyzer built into that, so it's an LM358 dual op amp, not a comparator. So that would be probably the receiver on this one. This is probably the transmitter because it's the one with the dedicated can in it and everything. But we will see. Okay, last one. Nope, not the last one, but second last one. This one is the ultrasonic. Bring it back into view. This is the ultrasonic distance sensor, the SR04. Again, I've done some projects in the past with these. Very, very simple and easy to use. So you have a pulse pin and a echo pin. So what you do is you power this up. When you trigger the pulse pin, it'll send out a ping through one of these ultrasonic modules, and then any reflection will be picked up by the other module and come back on the echo. And the idea is that you time the duration between sending out the ping and getting the echo, very much like a submarine and other devices. Other things that use range finding and stuff like that. They actually work very, very well. A little bit more complicated circuitry on this one, of course, because you're having to measure basically the speed of sound, so quite a few hundred miles an hour. So for short distances, that is a very, very short period of time. So there's that. And then the last module that's at least in bags is a 4 relay module. So looking at this one, actually that's starting to like what I'm seeing already. Each of these relays, the relays themselves are rated at 250 volts 10 amps or 125 volts at 10 amps. 10 amps 30 volts DC, 28 volts DC, etc. The PCB design, they've actually got isolation cutouts on the PCB, so if you were running this at higher voltages, it is adding a bit of extra isolation from the control circuitry here. Now, I've never recommended that you would use a board like this for driving mains anyway. But if you did, and it would be at your own risk, and if you've never played with mains, don't, get some help. But it looks like they've taken a few extra steps to protect the low voltage side from the high voltage side. Great for driving high powered LED bulbs, 12 volt car headlight kind of bulbs and halogens and things like that, or turning motors on and off, etc. What you've got here are 4 opto isolators on here, transistor drivers, a little bit of passives and some indicators, and then you've got a header here. So 4 outputs, 4 from a Raspberry Pi or an Arduino or something. Turn the relays on and off, control some high powered loads. So it's nice to see one of those included in the box. And that is everything that is the sensor module. Oh, before I go on to what's in here, the other item I wanted to show you, which often there's never enough, is these are also provided with a bunch of Spectra cables or ribbon cables, or there's lots of names for it. But anyway, you've got, looks like 10, 20, 30, 40 female to female cables and 40 male to male cables. Now, I'm not being sexist or anything like that. This is the traditional name for this kind of cables. The ones with the pins are called the male connectors or plugs, and the ones with the sockets are called the females or sockets, as I just said, and they go into each other like that. Provide quite a nice contact, let you do all your wiring up on your prototyping boards, your breadboards, interconnecting these to the boards, etc. So for example, to connect these pins here, you'd need to use a socket, so you'd have to plug these in. Now on the other end of these are more sockets, so they're not going to go into your breadboard very easily. Alright, but if you put a wire with pins on that end, then you've now got a socket to a pin. You can plug it directly into your breadboard. We'll go into that when we try a couple of projects out anyway. So what's in our box here? Well, all of these things are great and they let you play around with sensors and stuff like that, but you always want to try a few other things out and build up to them and have LED indicators and all sorts of other things. So this is a box of goodies with a whole bunch of things. So what we've got here are a handful of LEDs. You've got red, these are probably white ones, green, yellow, no blue ones, so 4 different colored LEDs, and it looks as you've got 1, 2, 3 of each color. So that's cool, bunch of LEDs. We've got a bunch of switch caps, button caps. Of course, for button caps you need buttons, so we have 1, 2, 3, 4, 5, 6 buttons here, tactile type buttons, and you can click the caps on the top so that you can use them and have different color codes. You've got square ones and round ones, and they're different colors of each, so you've got 6 switches. We've got a whole bunch more jumper cables. These are shorter, more designed for jumping on the breadboard. These have got round, they're more permanently connected. I found these ones are not quite as good as the square pinned ones. After they tend to start losing connections on the breadboards a little quicker, but as long as you're respectful of your breadboard and not jamming great big thick things into it, then they should be quite fine. The switches are potentially an issue because they have bigger pins on them, so they don't plug into the breadboard very well. So it might be worth soldering some pin strips on here, and there are some in the box. So soldering these onto these legs, they are all 0.1 inch pitch, so these are 0.2 apart, would allow you to plug into the breadboard much easier using a standard size pin. These, if you do push them in and force them in, you could damage the sockets on the breadboard. So I suggest you solder those onto these pins. A few extra dividers for this box. We have a 1, 2, 3, 4 100K potentiometers. So if you had something that requires analog inputs or a volume control with some kind of op amp or something, you can use these as volume control or a speed control for driving a motor or something. There are no motors in here though, but you can still use them, say, with an Arduino for analog to digital conversion. Now I do have a HD converter for the Raspberry Pi as well, so we can show you how to do that. A whole bunch of standoffs so that you can assemble this onto the plexiglass boards. We'll assemble this before we go. Short ones and long ones. We have some heat sinks. These are for the Raspberry Pi to provide a little bit of extra cooling. I've never actually found a need for these, but if you start enclosing your Raspberry Pi, they will get a bit warmer, and if you overdrive them, they can also start to get quite hot. So anyway, a couple of 3M thermal sticky pads on the back, so you can just adhere them straight to the Raspberry Pi chips, which is nice. And lastly, but not least, we have a pile, let's see how many different values we have here, of resistors. We'll talk about in a separate video how to read color code. So you've got 100K, 4.7Ks, good for pull-ups with switches and things, 1Ks, 10Ks, so 1, 10s and 100s, 100, didn't I already say 100? I did. Oh, that one is 100 ohms. Sorry, the way it's printed, it looked like a K, but I didn't look at the color banding on the resistors. So the first one I picked up was 100 ohms, not 100K. These ones are 100K. They're brown, black, yellow, gold. Gold means it's 5% tolerance. Is it 5%? Yeah. The brown is a 1, the black is a 0, and the yellow band is a 4. So that's a 1, 0, and then 4 more zeros, making 100K. The one I picked up first is actually brown, black, brown, which is a 1, a 0, and 1 more 0, which makes it 100 ohms. We have the last two, looks like 1 mega ohms, which has got a green, so it's a brown, black, green. And the last one is 47K, which is an odd value, but that's okay. I would expected something around 330 ohms for the LEDs, but I think because the Raspberry Pi uses 3.3 volt logic, you can probably get away with 100 ohms instead of 330. Usually use about a 330, 470 ohms for a 5 volt supply. Oh, there is another item in here which I haven't pulled out yet. So let's pull this out. Nothing else in there. Nope, 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 nope. All right, so the last item we have is an LCD display. Okay, there we go. So this looks like the 16 character by 2 line display. Very easy to interface to Raspberry Pis and Arduinos. It's based on a very old Hitachi type display that I actually even have one here. But the part number 1602A tells you it's 16 characters and 2 lines. It uses a parallel interface that has a fairly long-running standard protocol to talk to the display This gets back to the Hitachi protocol. And you can even use it with just 4 bits instead of 8 bits if you want to as well, if you've got a limited number of pins on your device that you're talking to this with. So what you have is a supply, a ground, a read pin, a reset pin, an enable pin, a data line 0 through 7, and then the last 2 pins is an analog and cathode, which are used to drive a backlight, and then there's one other pin, which I can't remember which one it is, which is used to control the backlight, sorry, the contrast. That's where one of these pots or something would come in handy. And you just vary the voltage on the backlight, the voltage on the contrast pin between 0 and 3 volts or something, and you can adjust the viewing angle or the contrast of the display. So that is the complete set of parts here. Pretty much everything. So we've got 16 sensors, a relay board, get rid of that, a 5 volt 2.5 amp power adapter, HDMI lead, network cables, HDMI to VGA adapter, possibly with an audio output, whole bunch of resistors for working with the projects, cooling, heat sinks for the Raspberry Pi, standoffs for mounting the Raspberry Pi onto the prototyping plexiglass board, pots, switches, LEDs, LCD displays, some jumpers to make things fit better onto the prototyping board, including the LCD display, the pots, and the switches. And that's pretty much everything. So let me just stop the camera here. I'm going to assemble one of the boards with a Raspberry Pi just to show you what it all will look like. So I'm just in the process of mounting this, and what I wanted to just show you is that the mounting hardware that came with it is what I have over here. So these standoffs, long posts here, these are the threaded ones. You also got a few screws. I've just already put the screws in here with some nuts, but these standoffs don't look like they will get used. The board that is used for the I/O expansion, which will plug onto the Raspberry Pi like that, comes with its own bag of bits, which is all these jumpers and little isolating washers, spacers, and some longer screws. So I think you get 2 plastic plates here. I think that these little standoffs are probably just to go in the corners to provide some height to the board. But there are no nuts to go with them. These big long spacers would thread onto these, but of course that will help you with the first one, but not the second one. Actually, will they screw on there? Yes, they screw on there. So you could jam those on, but they won't help you with the second one. So not quite sure, there's no PDF or anything to show you how to use this. Now, just to help anybody else that might buy one of these, because I think the kit is great, it's just got a couple of lacking things, like a document on how to use it, some example projects, for instance. But I will put together some notes, because I am planning on doing some projects anyway, including how to put this thing together. So what I'm going to do just right now is show you how to assemble one of these with the parts that are available. So let me just take that Raspberry Pi off. You can see that with this on here, this would bolt down, but that's all you'd be able to do. You need these longer screws to go in here that would allow you to put this little daughter board on. Now I've got a Raspberry Pi 2 here, not a Raspberry Pi 3, but that's fine. It's not an issue. So let me just take these out. Oops, losing all my little spaces. Don't want to do that. I need those. You also need to get one little set of spacers, not 2. So a little bit lacking. These are the little washers here that are used for spacing out the Arduino off of the, spacing out the Raspberry Pi off of the plastic case slightly. But there's only one set of those, not 2. Well, you get 5 of them to be precise. You really need to have 8, and because they give you 2 mounting boards, it would have been nice if they gave you 2 sets of screws, some suitable nuts, etc. So let's just put these bolts through here. 1, 2, 4, 3, 4, so it's not a huge deal, I don't think. Drop the Raspberry Pi on top. Okay, and as we probably have, everything was okay. Drop these on top of those, and that doesn't work either. Okay, it's a little bit interesting. That doesn't work either. I think if I just simply put the Raspberry Pi like this, it will probably all work. Yeah, that fits nicely. That spacer fits, that fits. So that screw is long enough to mount these together and provide some support with this board on the Raspberry Pi, but it is not long enough to go through this nice plastic base that they provided. That kind of sucks. And that's a little bit of a mission that they didn't really test that. So let me see if I can find some even longer screws and get back to you. Give me a minute. Okay, so I happen to have found a few screws that seem to work, so I'm just going to finish screwing this together. So you can see the screws that I've got are about a ½ an inch longer. Just putting this together. The spacers are the correct ones. I'm just going to drop them in. Because you're going to be plugging in and out things off this top board over time, it does pay you to put in the jumpers, the spacers. Okay, so that's got it together. I had to find some longer screws for mounting the Raspberry Pi and the adapter board onto the plexiglass case. I also had to find some M3 nuts so that I could use these little brass standoffs for feet on the bottom of the plexiglass. It doesn't come with any rubber feet, and I think that might be better in the long run. But anyway, aside from that, electrically this entire kit seems to be quite complete, and the accessories look to be great, and general quality of all of the boards and everything else seems to be pretty good. What is lacking, of course, aside from the nuts and the screws, are some example projects and things like the pinouts for a lot of these devices to tell you what pins are what. Now they are written on each of the devices, so it shouldn't be terribly difficult to figure it out, but having some example sketches for these would be awesome. This kit currently is $65.99 on Amazon. I think that's US dollars, but considering everything you get, the case you get it in, and all that stuff, I think it seems to be well worth the money. The lacking area really is some documentation and example projects. Now this would be equally well done as PDFs that you can download and print, or as just an online set of programs that you could download, maybe running under Node-RED or something like that. Anyway, I'm going to have a look at creating some sketches of my own, because programs, sketches would be Arduino, and running a few experiments with this, because I do want to do a few tutorials on using the Raspberry Pi anyway as an IoT device or as a general educational tool. So stay tuned for further videos. There wouldn't be much else you need to travel with your Raspberry Pi starter kit. Well, needing a Raspberry Pi, but once that's on here, we'll look at how well it fits back in the case now that I've got all of this done. I'll clear things away and try that. I haven't put the heat sinks on the Raspberry Pi yet. I'm saving these for my Raspberry Pi Model 3, which I may populate onto the other one. According to the website, and I'll put a little pop-up right here, they show the top board. Where did I put it? they show one of these boards being mounted above the other one. The problem with that, though, of course, is you really can't do your plugins unless you put the Raspberry Pi on the top one and just use it to lift it off the board. But then what's the point of the bottom one? You know, so you could use these longer standoffs to space it further off the bench, but that would just make it wobblier, in my opinion. So a little bit better for that. I would sooner, the way that this is all labeled and laser etched, I would sooner use this as a second Raspberry Pi. There's plenty of these little feet. HSU needs to step up to the plate really and get together a few of these sample apps, a PDF for the pinouts and assembly instructions and stuff like that, and just, you know, finish the kit with these few extra nuts and proper length screws, and that will be it. So anyway, that's the review part of it. Quick look at what's in the kit. As I said, 16 different types of sensors, nice complete range. You got gas sensors, you got real-time clocks, you got laser transmitter receiver, you've got ultrasonics, you've got wireless. You could build a little line follower, a burglar alarm. For your Raspberry Pi, you've got the power supply, you've got a HDMI to VGA adapter, networking cable, HDMI cable, you've got a whole boatload of resistors, jumpers, buttons and LEDs, everything you need to get started. So, you know, couple this with a Raspberry Pi and you'd be set to go for quite a while. Anyway, keep watching this space, because I'm going to now be doing a bunch of videos on how to do stuff with a Raspberry Pi, and I'll also be doing this with an Arduino. So I may drill a couple of extra holes on here and mount an Arduino board, because I think there's plenty of space for it. And if I use an Arduino Uno, there's a little prototype board for an Arduino Uno, as you can see, a few extra holes, and you could easily have both the Raspberry Pi and an Arduino Uno and a prototype in one kit. That would be even more awesome. So that's it for now. Hope you liked it. As I said, I will be providing all the links to HSU Shop, and I think the way I'll approach this is to show you the devices working without the Raspberry Pi or an Arduino first, and then add the Raspberry Pi and Arduino into the picture to show you how you can do sketches with them and things like that. So anyway, that's it for now. See you in the next video. And if you like it, give it a thumbs up. If you don't, well then don't. But this is the end of this review. Now, HSU Shop did not pay me for doing this review, so don't take it that, you know, I'm biased in that toward them in any way. And as I said, there are a few things lacking in this kit that they need to fix. But they did send me the kit for free, so I appreciate that. Thank you very much.